Okay, so the first step of this lab sheet is to locate and identify the ignition coils. So we've got this 2011 Jeep Compass. It's got a 2.4 liter engine. We're going to take the cover off. We're going to find those ignition coils, identify them. So for this one, we got to take the dipstick out. Then we pull the cover up off. And if we look down inside, we can locate those ignition coils. Now, this is one that always gets a laugh, but it happens every year. I'll come over and somebody will be working on a fuel injector instead of the ignition coil. So you want to make sure you have the ignition coil. The connectors are comparable, I guess, but the reality is the coils look significantly different. So we want to find those ignition coils. We're going to take and we're going to pull the coils out. So the first thing we have to do is unplug the electrical connectors. We'll be discussing those later in this lab. Then we're going to unscrew coil hold downs. So we've got those. Take and put our hold down screws in a safe place, not on top of the battery, obviously. Then we're going to pull the ignition coils out. When we pull the ignition coils out, we're going to examine them. We're going to look for any flaws on them. We're also going to keep them in order. So I like to lay them out so that cylinder number 1, cylinder number 2, 3, and 4. That way I know which one I'm looking at as I'm examining it. So if I take a look at cylinder number 1, the ignition coil here, I'll see some typical things on there. We got some oil residue, probably the O-ring on the valve cover gasket. Looking down here, what I'm looking for is any kind of burn marks on this. And this one looks pretty clean, surprisingly. I expected to see some issues with it, but I don't see any burn marks. I'm looking for obvious typical burn marks, but I'm also looking for white trace marks going along there that would indicate a high voltage leak. We call them ghosting. So cylinder number 1 looks okay. Again, doing the same thing, cylinder number 2, I see that oil residue. This one's got a little bit of ghosting on it. I don't know how well it's going to come out on the camera, but just a little bit of ghosting along the edge there. We can see it more so on the tip, that white shadowing. Again, that's an indication of high voltage leaking, so that can be a misfire. So we'll address that when we reassemble. Cylinder number 3. No significant issues, a little bit of ghosting on the end there, but not a big deal. And 4. Again, just a little bit of ghosting. So it looks like cylinder number 2 is the one that has most obvious issues. All right, now in the lab sheet, it asks you to identify the connectors. The way this is going to work is we've got our main connection going to the computer is going to be right here. This is the primary side of the coil. This is where we send voltage into the coil, generate a magnet, and control that magnet. So that's the primary connection right there. The secondary is going to be this end that attaches to the spark plug. So this will be our high voltage side. So the primary is going to be low voltage. We're looking at system voltage, 10 to 14 volts. The secondary connection is going to be our high voltage. So we're looking at thousands of volts. So we got those two connections, again, addressing the lab sheet questions. On the lab sheet, it asks you for 2 separate wires. Looking inside here, we have 3 connectors. So we're going to have to identify all 3 pins in the space on the lab sheet, just add that additional pin. We want to know what all 3 connections are on that primary connector. That's cylinder number 4. Now while I have it apart here, I'm going to pull the spark plugs out. Just because I have the opportunity, I'm going to take a look at it. This vehicle does have a complaint of intermittent misfire bucking. That cylinder number 2, the ghosting on cylinder number 2, makes me suspect about that. So I'm going to pull the spark plugs out while I have the opportunity. Alright, so I'm going to pull the spark plugs out. You'll notice that I've set aside my impact gun. I'm not going to use an impact gun to take this apart. We don't want to do that. We want to use the socket wrench so that we can actually get a feel for it. So if the spark plug is sticking, if it's not going to come out easily, we want to know that. And by doing this by hand, we can get that feel for it. Magnet, pull this out. Again, keeping them in order. Cylinder number 1, 2, 3, and 4. And again, we're going to do the same thing. We're going to look at the condition of the spark plug just like we did with the coil. So if I go in and I take a look at this, this has a nice clean burn pattern to it. All right, we can see it's got just like a light tan grayish color to it. Normal wear pattern on that center electrode. Could stand to be replaced, and I'm going to go ahead and do that. When I replace them, I always like to go with the stock plug. So this is an NGK, and I will go with NGK. I like to use what the manufacturer recommends. So cylinder number 4 looks good. Doing the same thing, looking at cylinder number 2, or excuse me, cylinder number 3. Good clean burn pattern. Cylinder number 2 is the one that had the issue with the arcing on the coil. So we're going to look at this. And it looks like fairly normal pattern on that, so I'm not concerned about that. And number 1 looks good as well. So these are just worn. There's nothing wrong. I'm not seeing anything on these spark plugs that would indicate a problem with the engine. No indication of oil burning, no indication of antifreeze burning, which is a relief because this one has a coolant leak that the customer's been ignoring for months. So that looks good. When I put these together, I'm going to make sure that I start the spark plugs by hand. No ratchet, no wrench. Start them by hand. That way I can make sure they don't get cross-threaded. I don't put anything on the threads. You'll see some technicians will put anti-seize on the threads. I don't recommend that. These threads are the ground path for the electrons in the spark. If we have anything on there that's going to interfere with that, it's going to affect the spark. I like to keep the threads clean. I don't put any anti-seize on there. I don't worry about that. Alright, so we've got the ignition coils out. We identified the connections on the ignition coils. The next thing we're going to do is we're going to look at the resistance of the circuits. Alright, so I've brought the coil over to the test bench here, and we're going to take some resistance readings on this. Now I've asked you to look up the resistance readings if they're available. To make life easier on the video, I've attached these 3 jumper leads to the 3 terminals inside, so we got 1, 2, and 3. And just to give you an idea of how this is set up, looking down at the top of the coil, I'm going to go from left to right. So 1, 2, 3. So we'll be able to see which terminals are which when you look up the wiring diagram. So on the primary side, we're going to take the resistance reading. So I'm going to go from terminals 1 and 2. So I'm going to hook up to terminal number 1, hook up to terminal number 2, and looking at our meter, we see we got an open line. Okay, 1 and 3, open line. So no continuity between 1 and 2 and 1 and 3. Now I'm going to go from number 2 to number 3, and we see that we get a resistance reading, so we'll get this stabilized. All right, so we get a stabilized reading of 1.1. Now, again, this is a very low reading, 1.1 ohm. So we want to check our meter, see what our meter resistance is. I got 0.4. So I have to take that 0.4 and subtract it from the 1.1. So we're looking at 0.7 ohms of resistance on the primary side of the coil. So again, 0.7 ohms. We want to check that against specifications for the primary side. The next thing we want to do is look at the secondary. I've pulled the boot off so that I can get access to the secondary. We can do that on this coil, but we can't do it on all coils. What I'm going to do is I'm going to check that secondary resistance going to the 3 terminals of the coil, of the primary side of the coil. So I'm going to go in, I'm touching in on my secondary end, and terminal number 1, we've got an open circuit. Terminal number 2 of the primary, we have an open circuit. Excuse me, I'm going back. So number 3, yeah, this is number 1, open circuit. Number 2, open circuit. Number 3, open circuit. So I messed something up. Aha, interesting. All right, so now we got resistance readings. Okay, so we got resistance readings. All right, that's 9.14 mega ohms. 9.14 mega ohms. I'm just going to go back and double check this. I'm going to flip my leads. Nothing. Okay, interesting. Okay, so when we look at this, when I have the leads hooked up with my positive lead going to the primary circuit, we got open circuit. When I take and I put my negative lead to the primary circuit, we get a resistance reading. Interesting. Okay, so what's going on here is that there's a diode in the circuit, and it's allowing the current to flow from the meter through the windings, the primary winding to the secondary winding, when we're hooked up in this direction. But when I hook my meter leads up in the opposite direction, it doesn't allow flow. Okay, so there's a diode in there. So we're looking at our secondary resistance on this one is 9.14 mega ohms of resistance. So again, we want to check that against specs, and that's how we test it. Now we're going to take and we're going to put this boot together. Probably not going to be able to see it with the way this is set up. Throw a light on there, see what we can see. But in the center, there's a little coil spring, and that coil spring goes through and makes contact with the spark plug on this side. Down in the center of the coil, we got that metal contact. That coil spring has to make contact with that metal contact in the coil itself, or else we won't get a strong enough spark. We'll lose voltage in that jump. So we want to make sure that the coil spring is protruding just a little bit. I'll actually use a little piece of sandpaper and clean that up, get a nice good connection. All right, and then I'll just take and it'll just pop back on. Good to go. So now we have the information we need for this lab sheet. You're going to research on how this is controlled by the computer, and I'm going to put it back together. Be well.